I'm here to talk about threat modeling. Threat modeling is my greatest passion. It's been my greatest passion for at least the last couple of years now. I've more or less entirely worked with threat modeling one way or another. I think it's a really interesting approach to security. A bit of my background, what I've been doing before. I started out as a software engineer, so one way or another, security has been with me throughout my entire career, even if I was working primarily with software development initially. I did some, software projects on mobile devices, done PlayStation 1 emulation on Android devices. Also been very interested in operating systems in general. Operating systems, infrastructure, networking and all that. I think that's part of the reason why I got interested in cloud platforms later on. Some people talk about build versus break in security, and I think I'm sort of a build guy rather than a break guy, even if I've broken a few things here and there as well. But been doing security in software development lately as well as a consultant, and now recently founded a startup together with a friend of mine called Oscar. Today it's about threat modeling. But before we talk about threat modeling, I think it's to sort of set the scene. Maybe I don't need to set the scene for people like you, but we obviously have a massive digital transformation going on out there, and it's happening everywhere in basically all verticals, all industries. And with that, as you know, comes a large degree of cloud adoption. Especially the last few years, it's been a massive increase in cloud-first deployments and cloud-native deployments. But there's a lot of other effects with the digital transformation, a large degree of autonomous development teams. And I think it's a long time ago when we realized that it's no longer possible to centrally control software development, like having central control over architecture in a larger enterprise, or having central control over QA, for instance. And a few years back, at least in most organizations, it started to become impossible to have central control over operations. And security is next on that train, in my opinion at least. It's not going to be feasible to have security done in a central team or security done by external experts only. We should utilize people with expertise competence to provide the gap analysis and feedback and the expertise that they are good at giving. But most of the security work must originate within the teams. And the obvious reason is that there's no other way to scale security and to build sustainable software with security in mind, and not only produce features. There are a couple of needs within autonomous teams. One is to have clarified and appoint a risk owner that can call the shots and decide on what's an acceptable risk appetite for the software that we are building. And that's not something that's necessarily constant over time, because we might be able to take higher risks in order to reach the market in time for, like, if we're developing a game, it would be good if it comes out in time before Christmas, for instance. That's extremely important in the gaming industry. Or if we have a certain window that we need to launch an embedded product, for instance. So risk appetite can vary a lot, but in order to know what risks we're willing to take, we need to know what risks that actually lie within the systems that we develop. We're going to go back to talk about risks later. But another obvious need when teams become more autonomous is that we need to build security awareness. And of course, there are many different ways you could build security awareness in development teams with various types of security training. There are tools like where you can practice and learn how to find vulnerabilities in code and things like that. You could maybe have someone run a session and demo a couple of vulnerabilities to learn more about how that vulnerability works and how easy it is to exploit and such. But threat modeling is also a really good way of building security awareness in teams and learning by practicing. So for those of you who are completely new to threat modeling is often described in 4 main steps to describe what is it that we are building, what is it that we're working on, basically. Second step is what could potentially go wrong in that? Or in other terms, what if an attacker does something towards this? Step 3, what are we going to do about that? What are we going to do to mitigate that risk or mitigate that threat? And finally, did we do a good job when attempting to do so? And but in more wording, it's more or less like identifying the applicable security requirements in a specific context. And context, you're gonna see that context is extremely important, and context matters a lot in identifying security vulnerabilities. But of course, there are recurring and common threats as well to consider, so we shouldn't completely ignore the common threats that arise. For instance, due to that we are using a certain piece of technology. Maybe we are packaging our applications in containers, for instance. Then there are certain threats that more or less apply to all projects that are using containers. Or if you're using serverless, then there are certain things, for instance, with Google Cloud functions that will apply to everyone using them. So, who's best at doing security? That's a trick question. It's not my intention to compete or sort of compare one towards the other. But I think it's important to reflect on this, that let's say that imagine if we say that team members are supposed to do all the security work independently. What do you think the biggest risks are with that? Any ideas? Sorry? Lack of knowledge. Probably an uncertainty of, like, did we cover the relevant threats? Lack of motivation, yeah. Bias, definitely. So, sorry? Lack of time, yeah. So what if security specialists does it instead? On their side, like, let's say we have a system. Can you do a threat model for me? No context. Yeah. Responsibility offloading, that's also important. Like, if we want a sustainable approach to security within autonomous teams, then the teams need to assume responsibility of security as well as all other quality aspects, like availability requirements and everything. So the magic is really in when these two competences collaborate. And I really, if you haven't already done so, I really encourage you to start threat modeling together with security specialists in the team that you're working in. Or the other way around, of course. If you're a security specialist, try to do threat modeling together with the teams. At least in my experience, it's very often that team members, they reveal the most severe threats just from like a couple of hours of discussion during threat modeling. So they sit on all the answers basically of the most severe threats. I don't bring much to the discussion. I just facilitate the threat modeling, and I ask a couple of questions, and then they have the answers. They know where the threats are. Most developers know a lot more about security than they might think. Or maybe they were just afraid of saying so. I don't know. So step one, what are we building? I think when describing that, it's extremely important to have a language that all parties understand. And at the right level of detail as well. So it could be that security specialists that help you have less experience in software development, but they know a shitload of potential threats to your application. So for that reason, it might not be the best way to describe what we are building by sharing code, for instance. So a language that both parties will understand is visualization. And I think it's a very powerful way, and it's a very efficient way to gain a mutual understanding of what we are building. In most threat models I do today, I use C4 as architecture diagram approach. There are several other ways. I'm going to show some other diagrams later in the presentation that are not C4, especially suitable for embedded systems and when building more operating system-like functionality. But in web backends and web systems and digital services, then I think C4 is really suitable for that. It's a good and flexible diagramming approach, and it's not a strict standard, but it's still a description of a couple of abstraction levels that are suitable for threat modeling. And it's not necessary to have all the different abstraction levels in C4 to do a good threat model. It's especially the two topmost levels that are important, in my opinion. The first one is context, where you put what is it that this team is building. You put that in the middle. In this case, it's an example e-store. And then you have a couple of users using that system. You have customers out there, and you have support users. Both of them are using basically the same software system. The only difference that we can see at this level is that support users are logging in through Azure AD, while customer users are logging in using Keycloak. And I'm highlighting those in particular. There are several other external dependencies, but I think it's very important to include the identity providers as part of the threat model, because there are many relevant threats to consider related to login and identity management as such. So that's always good to include. It's not included in this diagram, but it's also useful to include your CI/CD pipeline and control planes that you might have depending on how you deploy your application. But the context, that with a few simple boxes and diagram arrows, you can immediately understand what's the main purpose of this system. What are the main use cases? We won't know anything about what technology that is being used, not any protocols per se either, but it's a good overview, and it's something you can throw together in usually like half an hour with most of the teams. If we dive a bit deeper into the next level, container diagrams, there's a lot more details, and as you can see, now we have a lot more arrows as well to describe both how external parties interact with this, with the different containers within the system, and how the integrations towards external dependencies look. And now it's starting to become interesting, at least I think so, from a security standpoint. Because here we have a lot more details of what databases that are being used, what protocols that are being used between applications and databases and so forth. Of course, this requires some discipline when creating the diagrams. But I think that's a matter of practice and learn and trimming that in so that we get a sufficient amount of detail in the diagram. And if we work together on creating the diagrams as well, then that's an important aspect of ensuring the right quality level of the diagrams too. So now we can all of a sudden see that all external traffic going through an API gateway, all users are getting authorized or validated through a Lambda authorizer written in Python. I don't know if you can read that, but and then depending on what type of user it is, the JSON Web Token is going to be validated either through Azure AD keys or through the Keycloak signing keys. So I think that at this level, the second abstraction level of C4, then we have a lot to work with from a threat modeling perspective. If we dive deeper into more detailed diagrams, there might be additional details revealed, but at the same time, such diagrams require much more maintenance as well. If we keep it at this level, it's not moving that frequently or changing that frequently. So that's it about C4 diagrams for now. What about step 2, when we want to identify what can potentially go wrong? People often talk about risks. And I'm not going to bore you with NIST models and NIST risk assessment descriptions, but I borrowed this picture from NIST 830 for risk assessments, just to show that in case it's not obvious, there are risks at multiple levels. We have risks at an organizational level, we have potential risks for each business process in that organization, and we have risks on each specific information system. So one strategy when identifying risks could be to work from the topmost level and try to identify what are the biggest risks to our organization. And we might be, I say might be, able to understand what the biggest risks are. And if we do, then we'll need to break that down into what business processes that are involved, that are potentially involved in such a risk scenario. And then we'll need to coordinate and drive progress in assessing that risk further to understand how it can potentially be mitigated, what the likelihood is of that to happen, and so forth. I would argue that it's a lot better to work from the bottom, from the teams, from the actual technology being used. Because if we start at the bottom and if we start with each specific team to identify the potential technical risks in their context, then we can aggregate that to a higher level. For instance, if we would like to understand the aggregate risk posture for an entire business process. And it's also a lot easier to drive progress and drive mitigations to a specific risk. When doing threat modeling, even if it's actually risks that we are dealing with, we usually talk about threats instead, and threats usually have a threat actor and some kind of scenario that can occur, potentially occur. And when we identify threats, we need to think about defense in depth, or think from a zero trust perspective, if you like. Because it's no longer sufficient to assume that all perimeters are secure and say that as long as we focus on the endpoints and the API towards our system, we're safe. Because we'll see, and we can talk about that later in the presentation when I have a few examples. We see a lot of the attacks happening that are not necessarily originating from the public APIs and the public endpoints. And we can translate what threats actually mean in a risk language and the likelihood of that risk to occur or not, and what the actual impact would be. For instance, loss of data or loss of availability to systems, that in turn means loss of money. And vulnerabilities is, in my opinion, like, I'm not saying that it's all the vulnerabilities, but the threats that are not yet mitigated, that can be considered as vulnerabilities. And this is good data to provide as metrics to decision makers that are interested in understanding the risk posture or understanding what level we're at the moment. And that way we can calibrate and we can get leverage to do more security work. Because I don't know what you guys think, but I think it's this, in most organizations, there's a too high focus on feature development and too little focus on sustainability in that system that we're developing and getting security proactively into the system. So, how do we identify threats? In practice, when looking at the diagrams, this might sound odd. We talked about this just before the presentation, that some people might think that security guys or hackers will send some magic payload to the API endpoint, and that way they'll hack the system. But I think many of the attackers, whether they are white hat or black hat, they will start by analyzing the regular use cases, the regular data flows, and try to manipulate that one way or another, rather than just opportunistically send a bogus payload. Like a fixed payload might work if you have a middleware vulnerability or something like that, but it's a lot more often when you have vulnerabilities in the actual business logic. So for instance, if we have a case where a customer might view and purchase a product, then we can analyze that from an attack standpoint. So what if a threat actor would try to do something similar? And what if the end goal for the attacker is to manipulate the call being made to the order backend? Then that can potentially be manipulated by changing parameters in the first call. And if those parameters are not being validated or if they are not being filtered at all, then they could as well end up as parameters in the subsequent call being made to the backend. That's what people refer to as a server-side request forgery. And things like that is of typical interest when doing threat modeling, to just follow, okay, so what's the regular use case, what's the expected flow, and try to do something similar. Another example could be that if this means like purchasing one product or adding one product to the basket, what if an attacker would try to add 1 million items to the basket? Or just continue until it breaks? Most SQL databases have limited amount of storage. And I don't know about all database engines, but I know some database engines that will stop responding when they have filled up their disk space. And that can have quite severe consequences in some systems, when you can make the system stop completely just by filling it with database records. And similarly, follow the support user use case to see What if an attacker does something similar to that, but manipulates a certain parameter? But we should not forget about generic threats like, if we have a database deployed in AWS or in Google Cloud or something like that, then it's fairly common that it's accidentally left with public exposure. In some platforms, it's even the default to boot a database instance and have it accessible through the internet. So that means that it's only a compromised database password away from being a severe threat. If someone gets hold of that database password, then they could potentially extract or manipulate all the data in that database. And a final example, we can also look at external dependencies, like if we're heavily dependent on Keycloak to authenticate the users, what if someone exploits the control plane or the operations aspects of managing Keycloak? In this example, that's an external dependency. So most likely it's not relevant for this specific team, but rather a separate threat model being made for Keycloak only. But that's what typically happens when you do threat modeling with one team. You reveal that the security of this is not only dependent on what security activities that we do, but also the security activities or the lack of security activities in our dependencies. And very often this is also something that's software as a service, for instance, where you have an external vendor that's fully responsible for managing this type of component. And then it might be relevant to ask that vendor, do you have a threat model of your system? To calibrate and align with that, like, does that threat model correspond to the way we are using the application? In more concrete wording to identify threats and write threats, I often recommend to write based on a use case, to simply use the pattern, a threat actor does something to achieve something. Because they don't just perform a SQL injection. They perform a SQL injection because they want to delete data or extract data, or even worse, in some databases, execute code. And that part is important as well, like what's the potential end goal? Of course, we are just guessing, but if we have a potential end goal with the threat actor doing something, then it's a lot easier to translate that to what the likelihood is for that to happen and prioritize it based on that. And of course, there are different categories to consider. I already talked a little bit about this, but there's business logic, there's the design and implementation of the solution as such. Control plane, don't forget about the control plane. There are threat scenarios that can have extreme impact on a solution if someone gets hold of credentials being used by a CI/CD pipeline, for instance. And by all of these fancy frameworks and tools like Octopus, and I don't know why I mentioned Octopus, it was the first thing that popped into my brain. But like, of course, there are benefits with automated deployments, and I don't think there's another way to do deployment in many teams today. But think about what risks that relate to, especially to credentials. And with CI/CD specifically, at least with GitHub, for instance, there is OIDC integration where you can basically, without any specific credentials loaded into GitHub, you can allow access from a certain GitHub project to manage your AWS environment, for instance. And that way, you don't have to consider the threat where someone on the internet took those credentials and tried to manage AWS from somewhere else. So we take from the diagrams, we document threats, and these are what we end up with when we want to do step 3 and document the countermeasures. So for the first one, I talked about the server-side request forgery and manipulating a parameter, and that's typically input validation that can solve that. The other one is cloud configuration, where you can sort of course, follow the best practices. In AWS, there's something called AWS Security Hub, and most cloud platforms have something similar, Security Command Center in DCP. But those are without any context, so there will be tons of false positives if you rely completely on such tools. So it's a good at least to combine with threat modeling. And you can usually find the same issues by threat modeling instead. With countermeasures, it's important to think about the definition of done and document that as part of the implementation tickets, because it can usually take some time until someone dives into actual implementation of the countermeasure. And then it's going to be important to understand what's the scope of this ticket, and preferably have a link to the threat model as well, so that we know what is considered as good enough for this. And I think that you shouldn't strive for perfection when implementing countermeasures. Of course, in many threats, there could be like 2 or 3 countermeasures that are potentially interesting. Then at least implement one of them so that you have something in place, and then the rest could still be in the backlog for a certain amount of time, and then be considered for a later planning session, for instance. Sometimes the only way, or the only sufficient way, is to do logging and monitoring to understand when anomalies occur. So we might identify a threat scenario that is difficult to mitigate through input validation, for instance, or we see that, well, we can do parts of it with input validation, but still we don't know if it's sufficient. Then it's very important to combine that with logging and monitoring as well. So the final step, did we do a good job? Of course, if we do that analysis independently, it's going to depend on the state of the countermeasures. Did we actually implement them, or are they still in the backlog? But there's a lot more to that, and I think in terms of verification strategies, we can, of course, it's important to test the countermeasure implementation as we test any other feature, but also to do threat model reviews. And then it's preferable to have peers in other teams that are also doing threat modeling and review their threat model, and they can review yours, for instance. Or alternatively, if you have a security team, they can provide feedback and say, hey, you haven't considered CSRF threats, or you haven't thought about input validation or denial of service in this regard. And related to that is what I refer to as a gap analysis, where you do actual comparison towards reality. And I think that's where the penetration testers, security reviewers comes in, the actual security experts, to look at, based on your threat model, how does that align with actual reality and the actual deployment of your system? And are there any severe threats that you missed, or was the countermeasures insufficient? And of course, primarily with gap analysis, but also with reviews, we need to learn and calibrate our proactive efforts based on that feedback, so that the next time we'll probably not miss that type of threat. And we can probably utilize that in many other teams, and not only our team as well. But it's really about utilizing everyone's time as efficient as possible. And we won't be able to scale security competence in the way we scale software. I thought it would be fun to talk about a vulnerability that I found. It's 8 years ago now. And I thought it would be fun because it was as a preparation for Øredev. But it's not only to talk about old memories, it's because I like to use this example to show how powerful threat modeling can be. Because when I found this vulnerability in OS X, I was doing it the opportunistic approach. There's no guarantee that I will find a vulnerability. And there's definitely not a guarantee that I would find all the severe vulnerabilities. I just got lucky and found one. But the threat model representation, this is the other diagram approach I talked about. Threat modeling representation of this, it's simply two different trust boundaries. We have the non-privileged boundary, and we have the root space to the right. The tool that got me interested was the systemsetup CLI tool that could be used from a terminal to do various things like set the system clock and activate HTTPD or turn on SSH server in OS X and so forth. And I was interested in this tool because it was able to do that just by being an administrator, not being the root user of the system. It was actually checking with get effective UID to see if it was running as the root user. But that check was simply a soft check, so it could easily be patched in that CLI tool so that it got bypassed. But it wasn't just as easy as that. But the actual magic happened within something called admin framework, where admin framework instantiated an IPC service called write-config. And it made an authentication call, and then admin framework created a file. Yeah, you're reading it right. It created a file over IPC with arbitrary path, arbitrary content, and arbitrary file permissions. So why am I showing this? If we zoom in on this, this is something that's extremely important when doing threat modeling. If we focus on the data flows that passes trust boundaries, we will most likely find what an attacker might attempt doing. And that's exactly what I did. I just didn't call it threat modeling back then. I looked at what is admin framework doing, and can I do it from my own code? Of course, that requires, back then it required a lot of disassembly and all that of all these libraries. But if we think about that from a proactive and a more sustainable approach, in the team that is developing this write-config XPC service, imagine if we were doing threat modeling together with that team. We would outline exactly, okay, so here's the use case when someone activates HTTPD. And we would draw the arrows like this. And we would see that there is an authenticate call here with an Objective-C authorization callback, and that's pointing to, you can't go back, that's pointing to a specific piece of code that validates that I'm running as the administrator user. And then the admin framework is allowed to create an arbitrary file or file path with content and all that. So in a diagram like this, you can easily spot that there's an IPC method to create a file. And that doesn't look good. If you can create a file as the root user without being the root user, then everything depends on this authenticate call. So can an attacker manipulate this somehow? Well, there's one input parameter. And what I managed to do, due to the nature of Objective-C as a language, you could set that message to nil, which meant that it executed nothing to validate that it was an administrator. So authenticate became a no-op. So this took me several hours, but if I would have done this with threat modeling within the team, it could be a lot easier. And especially if we do it shift left and do it while developing, then it wouldn't take 6 months to repair as it did back then. Then it could have been repaired without even reaching the market. So to summarize, I've gone through the steps. What are we building? What can go wrong? What are we going to do about it? Did we do a good job? And the competences vary depending on what step you're in. So security experts are obviously better at what can go wrong or what is good to do about it. And especially, did we do a good job? But there's quite a lot that developers can do in threat modeling as well, either independently and then getting feedback afterwards, or in collaboration with security teams, which is really the preferred approach. And gradually, people will become more experienced and know how to do this without external assistance. So I think the future of threat modeling is going to be a lot more like this, where a larger portion of threat modeling is done by developers or team members independently. When I say developers, I of course mean all team members, including people that are focusing purely on automated testing or manual testing or whatever. But it takes a while to get used to this, but the more familiar you get, the more threat models you have done, the easier it is to start doing diagrams, identifying threats. If you're completely new to writing threats, threat libraries are very helpful with predefined threats that you can at least use depending on what type of technology you're using. So for instance, if you're using cookies, there are certain threats that applies to most, if not all, solutions that are have cookies involved. And I also think that in the future we can use threat models to augment other activities, like detection and response. If you haven't already done so, if you start to set up detection and response for a system without any context knowledge or anything like that, it's really a hassle, and it usually brings you back to starting to produce a threat model or something similar to that, a description of data flows and use cases to have an accurate detection and response. Disaster recovery plans, same there. We need to have a context to tie that to. Application security testing, of course you can do generic static code analysis and all that, but still, if you have a threat model as a starting point, then you know what type of application security testing that is relevant for this tool, for this system. Same with gap analysis. Of course, theoretically, we could see a gap analysis being performed by an external expert on like expected versus actual reality without any proactive measures at all. But it's a lot better to have the team do their very best and have a gap analysis based on that. Then it's going to be a lot more specific in the feedback as well, and focus on the actual data. Code reviews, it's no longer possible to do code reviews of all code in most systems. So it's a lot more preferable to have code reviews on specific threat scenarios or specific countermeasure implementations. And by that, I'd like to thank you for coming. Hope you found it interesting. And are there any questions relating to this? You're free to stay afterwards. I'm going to stay for a while here. So if you want to ask anything, just... Yeah. Sorry? I wasn't planning to. I don't know if there is something through Øredev where they... Everything is recorded. Yeah. So there's videos. Yeah. But if you don't get access to it, drop me an email and I'll fix that. I actually have a screen capture of everything up there. So awesome. Soon on the internet. Thanks, everyone.